cubic root of the x cubic is x, and cubic root of 216, I have no idea. Oh, you memorize something, but no. You put in the calculator, no? You put in the calculator, cubic root, the majority of calculator have higher order roots. In my calculator I have in my hand right now, I put 3, is the index. I press the key to indicate higher root, parenthesis 216 of the parenthesis, press enter, S6. S6 because I want to double checking power 6 times 6 times 6 is, I put 6 times 6 is 36, and 36 times 6 again is 216. So my cubic root is x and 6. So in my mind, this guy represent A in the formula, and this guy represent B in the formula, right? And the formula say, I want to copy the formula, and the last time I copy. A cubic minus B cubic is equal A minus B, A squared plus AB plus B squared. This is my formula. And our specific example, x says x cubic minus 216 is equivalent algebraically x minus 6, because A is x and B is 6. It's a B. Entonces now the trinomial look like a little bit complicated, but no, not too much, because A is x, entonces x squared plus multiplication both together is 6 and x together is 6x plus square the big is 6 times 6 is 36. Boom, final answer. Option, I suppose que is, be careful because it's similar. It is, D because it's plus. Do you follow me? ¿Es easy or no?
Professor.
Uh-huh.
Question, how did you get 6?
6 was Mr. cubic root 260. Okay, I did with the calculator. Or can do by hand if you multiply, but this is try and error. 6 times 6 times 6 3 times. 6 times 6 is 36. And 36 times 6 is 260. So I need to find one number to multiply by itself 3 times is equal the number inside the radical, que es 216. In this case, I discovered que 6, but I discovered because I put in my own calculator, no? So I recommend que everyone have a calculator, no sophisticated, no expensive, cheaper. I recommend at the beginning was TI Texas Instruments 30X. It's super nice, super cheaper. Okay? Do you understand, mister, where I come from this 6 or no?
Yes.
Okay, cool.
Yeah.
Continue, another example. This is example 40 and 41. 41 is, it's easy, y cubic minus a. Okay, guys. We are doing now this kind of problem, no? This is repetition. But in the real life, no. In real life, you have totally miscellaneous problem. And so the first thing you should do is identification. Your identification, what kind of problem we face. All right, binomial, two guys, is subtraction differences of cubic, because the exponent is 3 or multiple of 3, and I know very well that A is perfect cubic number, no? So you apply cubic root here and cubic root here. Cubic root y cubic is y, and cubic root A is 2. So using the formula, under the supposition that this is A and this is B. Is y minus 2, y squared plus 2y. Okay, remember, 2y will come from 2y. It's the multiplication, this and this together. A and B. Plus square the second, que the second is 2, and 2 square 4. Boom. Okay, this is that. Again. You follow me?
Yes.
Okay.
Yes, follow me.
1000 p cubic minus 1. Again, binomial, difference of cubic. Cubic root that guy, cubic root of 1000 is 10, right? Because 10 times 10 is 100, and 100 times 10, 30, 1, 2, 3 is 1000. Entonces 10p, you know, 1 is a magic number. Any power and any root always is 1. Okay, entonces this is my A, this is my B. I copy the formula. The formula say 10p minus 1. Be careful now. The formula say square this, que es 100p squared. Where come from this? 10p squared. Es obvio que es 10 times 10 is 100p squared. Plus multiplication both. In this case, a coincidence, que es 10p, plus square 1, que es 1.
I have a question. In the first parentheses, wouldn't it be 1000 p?
In the first parenthesis, you say here.
Yeah.
No,
Because
okay.
you have to square root it.
Yeah. Square root, no, cubic. Okay, look.
Yes.
Compare the formula. The formula is A cubic minus B cubic is equal A minus B, A squared plus AB plus B squared. So in this specific example, the cubic root of the 1000p cubic is 10p. And this is my A, I copy here. And the cubic root 1, of course, 1, I copy here. You see more clear now?
Yeah.
Yes, but Professor, I have a quick question. In the second parentheses, why do we need to put 10p again? Is it because we're multiplying?
Yeah, it's A and B. A and B. Who is A in this specific problem? 10p. And who is B? Okay. A1. It's a coincidence because you know that 1 is invisible multiplier.
Okay.
Okay? Another scenario, no. Another example, no. But in this case, a coincidence. Okay?
Okay.
Entonces, we erase this, we erase that. Next problem, bueno, I suppose que the answer was B, no? Suppose 43 is 8r cubic minus 27. Again, identification, difference of cubic. Automatically, you compute the cubic root, this guy. It's 2r, and this is 3. Wow, this is my A, and this is my B. I plug it in my formula, and that's it. And my formula is 2r minus 3, A minus B. Entonces, the complicated part is that inside the trinomial, but it's easy. It's square this guy is 2r squared. 2r squared is 4r squared. Copy 4r squared plus multiplication both together is 6r plus square 3 is 9. Okay. So 2r minus 3, 4r plus 6 plus 9. There you go, D. No problema.
No problem. Got it.
Entonces, this 44, 45, 46 look like horrible. Pero no, because I recommend que you using your own calculator, no? Let's do it. This is a big, is 729 y cubic minus 1000. Well, I know, I know that the square root 1000 is 10. I did before. And the square root, cubic root, sorry, cubic root of 729, I have no idea. But let me try. So you put in my calculator 113. You press second, select the function to apply higher root. In the parenthesis inside, put 729. Put the parenthesis, press enter, and 9. And 9. 9, of course, 9y. So I compute the cubic root, not only numerical parts, the variable part. And this is my A, and this is my B in the formula. Therefore, I copy. Binomial, trinomial. 9y minus 10. 9y squared is obvious que es 81y squared. Plus multiplication both 90. Where I come from 90? Multiplication 9 times 10. Yes, you multiply 9y times 10. And 90y. Don't forget the verb. Plus. Plus square 10 is 100. Oh. Final answer. Something like that.
When I put the square root of 729, I got 27.
When you what? You put
The square root for
it's not square root.
It's cubic root.
This is the
oh,
idea. Okay. Entonces, en MAT1033 30X Texas Instrument is cheaper calculator. You put, for example, you put 3 first. Suppose this is the display. You put 3 first. So you press the key second. My calculator is blue color. And you press the function. Okay, the function is like that. Radical x. Now we have a square root, the classical regular square root, in which the index is 2 invisible. But when the higher, there's cubic root, 4 roots, and so on, you press the index first, you press that function que is in second, and the specific key can have this figure, and you see something like that in the display. This is my display. Open parenthesis, you put the number, is 729. Close the parenthesis and press enter. Equal, it's the same. Get 9. Do you have calculator? Everyone have calculator. It's important, at least in that part. Or you can use in the smartphone calculator, no? Depending, no? So you master this operation, no? You don't need to memorize this stupid cubic root. Put in the calculator, okay? So what is the answer? Oh, yeah, I select yes. SP. Okay. Now, look like easy or complicated that part? In my opinion, it's easy, no? Because it's formula. It's the formula, only formula. But let me see, it's S cubic. How you recognize that this is 125 T cubic? It's obvious que in this case it's a sum of cube. Yes or no? But I need to investigate What is the cubic root 512? And what is the cubic root of 125? Remember, cubic root means okay, you need to find one number and multiply by itself 3 times, give me 512. Okay, the same number. This is the idea behind cubic root. Si ese square root is only 2, si cubic root is 3, si for root is 4. Okay, entonces now I put in my calculator, of course. 3 second higher root. I put inside the parentheses 512 plus the parentheses. Boom, the answer is 8. So this cubic root is 8. And this cubic root is 5. The 5 times 5 is 25. And 25, 5 times 5 times 5. 5 times 5 is 25. 5 times 5 is obvious. Okay, so when you compute the cubic root, this is AS using the variable also, and the cubic root is 5t. Okay, this arrow, the action of this arrow obviously is cubic. Makes sense? Now I am ready. Try the finals. One binomial, a trinomial. Inside the binomial, A plus B. Es A plus B because it's sum plus. Entonces es AS plus 5t. Inside the trinomial, you have a square. Square AS. Square AS is 64x squared. Remember the formula is minus here. Multiplication both. Both is 40. Where come from 40? Multiplication AS times 5t. And 40 ST. Plus square the second, que es 25 squared. 5t squared is 25t squared. Done. Entonces, let me try. I suppose que es this. Suppose. Ah, yes, it's this. It's this answer. Cool. No problema. Yes, everyone follow me, right?
Yes.
Okay.
Yes, Professor, we're following.
The last one, que 46, is 512. The C, no? C cubic. We did before, que cubic root plus 343. Factorization of this expression, binomial, a sum of cubic. I know, que cubic root by 12 was A, no? I need to determine cubic root 343. Okay, I have no idea. You put in the calculator cubic root. Okay, same function. In the parenthesis, 343. Oh, A7. A7. So the cubic root of this expression is AZ. And the cubic root of this is 7. Ready. I interpret it like A and B. This is my A and this is my B in the formula. Binomial, trinomial is AC plus 7. And square this is 64. C squared minus, because the formula have minus here, multiplication both 8 times 7, 56. C, don't forget the variable, plus square the 7, que 49. Okay, Entonces, AC plus 7 is the first one. So this is the first option. Okay? It's easy. I like that. So binomial is easy because it's just a formula. You need to remember apply a cubic root or a square root, depending if it's squares, it's a square root. Si es cubic, it's cubic root. And you apply the formula and that's it. The complicated part is trinomial. The trinomial, we need more skill in arithmetic because it's a challenge. Always find the number que multiply each other, blah, 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 blah. Entonces, pero in this case, the cases. Okay, now let's start application. What is useful? What is the application for the factorization? Factorization is frequently used in algebra. That's the reason that you need to know. And in the next algebra, we continue to apply factorization. In the calculus, we can apply factorization. This is forever, right? Now, the first application is solving quadratic equation. Solve quadratic equation. Okay, we study in the other chapter linear equation. A linear equation is super easy. Linear equation, I recall linear equation, and it's important that you see the differences. 2x plus 3 equals 5. Wow, piece of cake for us. With 3, 2x is equal to 5 minus 3, que es 2, divided by 2, divided by 2, divided by 2, and 2 divided by 2 is 1. Done. End the story. Linear equation. Okay? However, the quadratic equation is impossible doing it that way. No. You, what should I do? Well, you, example, doing the example 47, no? Is n squared minus 49 equal to 0. This is quadratic because the exponent in my variable is 2. Okay, it's quadratic. So now there are many ways to solve this. However, one fantastic way is factorization. So you, for example, you ignore. So this is equation. Look, it's important that you understand the difference between equation and expression. Algebraic expression. So far, the only thing we are doing so far to this was factorization expression. Because I don't see equal sign in any problem. When you see equal sign, this equal sign indicates que es equation, right? No equal sign, expression. And expression, never you can solve it. You factorization, maybe. So now, when you face this problem, you temporarily, you forgot the equal sign. And you focus it 100% in the algebra expression. And you factorization this. They see, wow, it's a binomial. Nice. Wow, it's a difference of a square because the exponent is 2, and I know very well if 49 is perfect square number because 7 times 7 is 49. If you apply the formula, open two parentheses, apply square root in this case, is m, square root is 7, and don't forget plus and minus. And you restore the equal sign now. And you apply one super important thing. It's the zero factor property. What is that? When the two expressions multiply each other and it's equal to 0, it's because the first is 0, the second is 0, or both are 0. But it's easy because you solve them one by one separately and we connect in both. So basically is a -7 and this positive. So what is the solution? Well, the solution for this quadratic equation, que normally Not always, but frequently, 99% of the time, the quadratic equation have two solutions. Solution set is -7 and +7. Or +7, -7. The order is not important. Let me see. Entonces in this case, they write in this way, separated by comma, and sorry, not necessarily curly bracket. Do you follow me? Okay, so essentially, we take the expression on the left-hand side, your factorization, and you apply the zero factor property. Boom, end the story. Let's practice. Entonces now you see miscellaneous. You see binomial, trinomial, polynomial. Wow, crazy. Okay, suppose 48 x squared plus ax minus 20 equals 0. Okay, this is my quadratic equation. I need to solve it. Never we can solve it like a linear equation. You moving this to the other side. No. Now factorization. So what kind of expression we have on the left-hand side? Oh, we have trinomial. And the trinomial, by the way, is easy because the coefficients here are 1, no? Entonces now automatically I open two parentheses, boom, boom. I put a variable, que es x, and our problem, I try to find the combination that open the door. I need to find two numbers que multiply, give me 20, and somehow when you're adding or subtracting, give me 8. Do you see the combination or no? Two numbers, they multiply each other. Entonces now, remember the mnemonic divide que I explained. You take 20, it's important guy at the beginning. You separate. What is the potential factor? It's 20 and 1. 10 and 2, no? And you continue. Divided by 3, no. Divided by 4, yes. Que 5 and 4, no? This is the factor que when by each other give me 20, no? And you addition, subtraction, give me 8. It's obvious this combination. Because 10 minus 2 is 8, correct? Well, at least I try. You put 10 and you put 2. Who help with the signs? Different sign or same sign?
Different size.
Different sign. Who is positive? Who is negative?
10 is positive.
Absolutely perfect. 10 is positive and 2 is negative. So now apply the zero factor property. X plus 10 equals 0. Es obvio que es negative 10. And x minus 2 equals 0. Es obvio que the solution is positive. So the solution is solution set is negative 10,2 positive. Okay, notice the sign in the equation is opposite to the solution. So some students doing too fast. And when you see the factorization, you see, it's negative 10 and positive 2. Negative 10 and positive 2. Negative 10 and positive 2, like option A. Cool? It's okay? Let's try next page. Let me try to find. Twice. Chapter 2. I don't know. See, it's that page. You try this and this. Yeah, I suppose it's this. Yes. Okay, got this no now. Okay, continuation. This is example of the solution quadratic. Look like horrible. Let's try our best. Okay, look at that. 49 say 5x squared minus 30x plus 40 equal to 0. Okay, what should I do? I am totally lost. In the left hand side of this equation, the right hand side always is 0, you know? You see, it's not 0, you guarantee it's 0. You move everything to the left. And the right hand side is 0. Entonces, in the right hand side of this equation, I have trinomial. But the problem is identification. What kind of trinomial? This is the challenge. Well, I suppose it's complicated, no? But I suppose wrong. Because it's super important, guys. You put together the technique of the factorization. Remember, number one step is GCF. If the GCF is 1, it's equivalent to say que do not exist. Well, entonces, obviously, we continue. In this case, factorization trinomial. But don't forget this step. Okay? Trinomial. But don't forget this step. Okay, some student and even tutor I see que forgot this step. Entonces now, to say you complicate your life because 5 times 40 is 200. 200 is too much. So you apply maybe a factorization try and error, que is horrible. No. You see que GCF is 5. 5, 30, and 40. Oh, it's clear, at least for me, that that number is divisible by 5. No, 5 is a prime number. 30 is 215, 35. And 40 is 220, 210, 25. Ooh, look at that. At least we have 5 common here, here, and here. Yes or no? So I strong recommend that you spend 2 seconds, not 3, 2 seconds to investigate the GCF. Oh, GCF 5. Now we have, you factor out 5, you have x squared minus something is 6. Remember, so you factor out the red part and stay the black part, 2 times 3 is 6x plus 2 and 2 is 8, no? Is 8. So far, I did GCF. I finished? No. Because in that moment, don't forget equal sign and 0. In that moment, I have trinomial. I don't know exactly what happened with this trinomial, but it's trinomial. So it's easy trinomial because now coefficient is 1. Do you see the advantage of the GCF? So you are doing without GCF, you complicate your life. And no, well, you get the answer, of course, but it's too long process. So you copy the variable as x and try to find the combination to open the door. What is the combination to open the door? 8. You take 8 and investigate. 8 times 1 is 1 possibility. I suppose it doesn't work. But 4 times 2, yes, because 4 times 2 is 8 and 4 plus 2 is 6. 4 and 2. What about the sign? Who help me with the sign? Who help me? I'm confused.
Both are negative, right?
Exactly, you are right. Both are negative. Could you explain why?
Because we need two numbers that multiply are a in positive 8, but when but we need a negative 6 less than 4 and
Cool. She said when you multiply negative 4 and negative 2, I know it's positive 8. Exactly like that. And when you adding negative 4 plus negative 2, oh, the number with the same sign adding gets 6, but we have the same sign, get negative. Exactly satisfy this condition. Remember my mnemonic device to determine quickly that part is this sign is positive, expect the same. Same means plus plus, minus minus. How do you know? Well, at least I discard different. Different no apply in this scenario. This is saying, and according to this idea. However, look at this sign is always the sign of the bigger number. Who is the bigger between 4 and 2? F4. This is negative and the other is the same. Okay. Either way, guys, either way. The way you prefer. The way you much better understand. I don't want to enforce anything. This is the beauty of the mathematics. We have different ways. You're doing correct. It doesn't matter the way, you get the same answer. Okay, entonces now zero factor property, pero you have three factors, or apparently you have three factors. 1, 2, and 3. Pero 5 never is 0, because you write 5 equals 0. It's a contradiction. O sea, the coefficients do not participate in the game. No. Only the factor que contain variable. So it's obvious que x minus 4 is 0 and x minus 2 is 0. If you want, you put directly, solution is x equal positive 4 or comma, whatever. Everyone understand very well. X equal 2. So it's 2 positive and 4 positive. Like that. Boom. Any question? Do you understand very well or confusing? Very confusing, eh? No? No? It's clear? Sure? Wow, you're good. Now let me see. Yes, Eric Troncoso says clear, Professor. Good. At least one of them. For you are good students. Yes. Another two never understand this part. Let me try the next. The next look like horrible. 15 y squared plus 22 y plus 8 equals 0. Wow. It's horrible, yes. Okay. This is obviously we have no GCF. So GCF is 1. No, useless. Cannot do anything. It's important in this case. So definitely, this is complicated triangle. And you multiply this guy and this guy. You multiply 15 by 8 is 120. 120 look like horrible, but not too much. I suppose I try 15 and 8. Oh, 15 and 8. Pero es que 15 times 8 is 120, no? Entonces I try to find the combination that open the door. 8 is 12. 10. Oh, maybe. Okay, there's 120. I have no idea. I lost. It's 120 times 1. No, this is too big. Another combination is 60 times 2. Okay, you divide by 2, you divide by 3, que es obvio, divide by 3 is 40, no? 40 times 3. And you mentally adding or subtracting this number because my goal is, remember, to get 22, no? Entonces, divided by 4, 1, 2, 3, 4 is 30. Times 4. We almost, no. By 5, 20 divided by 5 is 24 times 5. No. But when you add it, it's 29. Subtracting is 19, I guess so, no? I need 22. By 6, yeah, by 6, 120 divided by 6 is 20. 20 times 6. But when you add it, it's 26. When you subtract it, no. But it's 22. I need 22. And you go to 7, no. 8, yes. 8, let me see. 8 is possible. No, 8 is not possible. But you continue. If you discover 12 and 10. 12 and 10 together is 120. When you multiply, when you addition is 22. And I suppose that this is the combination. Okay, sometimes it's not easy to find the key to open the door. And remember the organization. The organization is you bring down 15 by square. Bring down 8. Or with the corresponding sign, get positive. And you split 22 and 12 and 10. In this case, both positive. Because when you adding each other, give me 22. Entonces, bueno, what is the reason? Can I write like that? Positive is clear. If one guy is negative, or both are negative, the answer is negative. I need the answer positive. But what is the reason can I copy here and that way, or no in that way? The answer is the same. It's the same. I'm perfectly work in both ways. However, I need to make a decision, no? One way. And remember grouping now. Grouping is separate two couple, or we using that color, red couple, green couple. So the GCF and the first couple obviously is 3. 3y. So 15 is 3 and 5. 12 is 3 and 4. 4 is 2 and 2. But at least we have one common factor, 3. A factorial. And the y is common also, no? I stay open parentheses. Basically, the thing we're doing is GCF. GCF separately in each couple, red and green. So stay 5y plus 4. Cool, right? And the GCF and between 10 and 8, 10 and 8 is 2, no? I guess so. 2, 5, 4. 2, 2. So the 2 is common. The GCF is 2, and the green couple, 2 only 2. No y, because we have no y here. So it's 5y plus 4. Now I am happy, because this expression is exactly the same of this. That means I did well. Your factorization, 5y plus 4. In the last parenthesis, 3y plus 2. Everyone follow me so far?
Yes.
This is typical complicated example. Now we almost finish, because I need to restore the equal sign. I forgot in this process, in this long process. Actually, the thing we're doing is solution for the quadratic equation. And you apply one more time the zero factor property. Copy each property separately and solving like a linear equation. Okay, let's do it. It's easy. 5y is equal to negative 4. I move 4 to the other side, divided by 5 both sides. Y alone is negative 4/5. Boom, first answer. Second answer, 3y equal minus 2 divided by 3 both sides. Y alone is negative 2/3. Second answer. Well, it's similar. The expectation we expect two solutions in the quadratic equation, no? Is negative 4/5 and negative 2/3. Negative 4/5 and negative 2/3, like the option C. Everything is clear, guys? Or very, very confused? Of course, you need to practice. And the practice you need to do by yourself, not by yourself, because you can call our help. Any problem that you are doing in the homework and you don't know, you email me. Yeah, I reply the solution with the explanation. I try, no? The piece of paper. Another possibility is, remember, today I am in the campus, in the STEM lab, from 12 to 5 p.m. Any problem you have, you bring your own laptop. They can help in the homework and the test. No, but in the homework, yes. Okay. Okay, let's move on to next example. Next example is, we are doing well. We're doing well. I'm so proud of this class. This class is good. Fortunately, every class I have this semester is good. Good means that the student dedicate. Not super smart, but always dedicate. Try to do the homework, the assignments. Okay, 51. 51 is 6k squared minus 17k minus 3. Wow, equals 0. Again, quadratic equation. And this quadratic equation in the left-hand side, we have trinomial. What kind of trinomial? Well, we have complicated. You know, get complicated because we have 6 here. And see, no, 6 is easy, but 6 is complicated. And the way is multiplication, this and this. It's 18. Remember, I don't care the sign. The sign is not important now. Because the only thing that we are doing is try to find the key to open the door. So you analyze, slow down, the factor of 18, que somehow give me 17. It's obvious. 18 is 18 times 1. 18 times 1 is 18. 18 minus 1 is 17. It's a combination that open the door. So I bring down 6k squared. I bring down minus 3. Yeah, I split 17 and minus 18k plus 1k. Because and you put the proper signs. If my answer is negative 17, it's obvious that 18 is negative. And 1 is positive, there's a subtraction, and put the sign of the bigger number get negative. We come back to the beginning, but I don't want to combine back the beginning. No, I take advantage of this moment because I did the conversion between trinomial 1, 2, 3 and polynomial 1, 2, 3, 4. So we have the famous two couple, the red couple and the green couple. Cool. What is the GCF? GCF and the first couple is 6. So 6k. So we have k minus 3 plus 18 times 3, 6 times 3 is 18. And the second couple and the green couple, we have no GCF. Wow. GCF is 1. Here is 6k. And 1 is invisible. This is k minus 3. But one more time, I can see the same factor. Therefore, I am happy. So I copy k minus 3. Parenthesis, the last one, 6k plus 1 equals 0. Don't forget that we are solving equation. Same equation, have equal sign. Okay, now the last moment, que es easy. Separate into linear equation. That one and that one. It's obvious that k is 3 positive. One solution can satisfy this equation. And here, 6k is equal to negative 1 divided by 6. We get the fraction. And k is negative 1 over 6. Two solutions, one positive, another negative. Factorization is positive 3 and negative 1 over 6. What is the first is option A? That one. Okay. Oh. Now it's important. The organization is extremely important. I try to do using my own way. You know? So now, at the beginning, maybe you imitate my way. When you get practice, you maybe create your own way. Is keep some step. Okay, I repeat too much because I am teacher, no? Entonces my job is repeat. Now the last one, que es super easy. Wow, the last one is super easy. It's a quadratic equation also 7m squared 3m equal to 0. Okay. And sometimes happen que our quadratic equation is incomplete. Okay, the classical format, the standard. Format 4. The quadratic equation is one number, x squared, this is a variable, x is a variable, a is just a number, bx. So you see, the first guy is a quadratic. It's super important because see, this is missing. This is not quadratic. So the name of the whole classification for the equation, so you see one guy gets square, no, actually quadratic. Okay, this is the most important, guys. However, sometimes happen que B is missing or C is missing. In another example, no? In this case, C is missing. So we have the quadratic, it's the most important term. This is a linear because the exponent is 1, but C is missing. Okay, no problem, but it's quadratic. Okay? Sometimes B is missing, sometimes C is missing, but never A is missing. Sino it's no quadratic, linear, and entonces we solve it in the traditional way. But in this case, binomial, wow, pero it's perfect. It's different of a square, sum of cubic. No, it's GCF. You find the GCF, I can see the only GCF that we have is M. M is GCF. I factor out M. We have 7M minus 3 equal to 0. And that's it. The only GCF was the technique you apply. No trinomial, no by special binomial, no. GCF. And I don't know, maybe it's confusing or not for you. Okay, M alone is a factor. And 7M minus 3 is another factor. So one solution is M equals 0, is this. And 7M minus 3 equals. This is clear, this 0. But this no. This is 7M equal 3 divided by 7. M is equal 3 over 7. Answer. This is 0 and 3 over 7. Like the option. Cool. Everything okay or no? So you need to be aware. Solution quadratic equation. Binomial, sometimes trinomial, but anything you need. Factorization binomial, factorization trinomial. Don't forget GCF. When the GCF exists, the word exists is not proper. It is when there is no one, you need to factor out. That's the first thing you should do. Be careful. You try to do problem of the factorization without GCF, and the GCF is no one, so you complicate your life. Totally useless. Totally no sense. Okay? see I have here. Yes. Okay. Let's do it now. Another application of the factorization. In this case, is two simplification rational, two simplification fractions. A fraction or algebraic expression que is called a rational. No? Rational is a polynomial divided by another polynomial, blah, 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 blah. For example, 53. 53 is m squared minus 4 divided by m squared plus 4m plus 4. Okay, so what is the job? I don't understand. The job is simplify. Simplify. What means simplify? Simplify means you factorization separately, expression in the top and expression in the bottom, and you cancel out some common factors if exist. No? If do not exist, no. However, you can do that. So you focus on this expression. I realize, oh, it's different of a square. And different of a square, I open two parentheses, square root is ISM, and square root 4 is 2, and plus and minus. Done. I did the factorization of the binomial and the bottom. Now I want to focus in the trinomial and the bottom. I suppose it's easy trinomial. Yeah, because coefficient here is 1. Open the parentheses, I put the name of the verb exam, and the combination that open the door is 2 and 2. Because 2 times 2 is 4, and 2 plus 2 is 4. By the way, it's perfect square. I don't see, but it's okay. It's plus plus. Okay, right? It's plus plus. Therefore, I saw, wow, look at that. This guy is canceled with this. Because any expression divided by itself is 1. Okay. So there are no reason to write like that, because this is equivalent 100% n minus 2 divided by n plus 2. End the story. Boom. Simplify. We see n minus 2, n plus 2. That one. Do you see on?
Yes.
That was 53 problem. Now 54. 54 is 3x plus 2 divided by 15 x squared plus 22 x 8. Wow, what the hell? Okay, and in the top, we don't need to do anything because it's one binomial, no? But no square, no cubic. You say leave it like that. And the bottom, yes. And the bottom is the famous problem I did before, no? Before this guy. See. Oh, yes. Yeah, I did before, but that's okay. I want to repeat. This is complicated trinomial, no GCF. This is 120, no? And the combination that opened the door was 12 and 10. You remember, right? Because 12 times 10 is 120, and 12 plus 10 is 22. And down 15. And down 8. Split 22 using 12x 10x. Wow. 8. 8 come from this. Now grouping. Grouping. Red and green. The ECF was, don't remember, 3, no? Yes. 5x plus the GCF was 2, no? Is 5x plus cool. I like that. Because in this moment I see that this and this is the same. Again, we have 3x plus 2. Okay. Then just copy that one here. 5x plus 4 divided or multiplied by 3x plus 2. And you see, wow, look at that. This is canceled. This is canceled. Who is canceled? Let's stay alive. And the bottom, obviously, 5x plus 4, no? And the top, nothing. And nothing. Remember, 1 is invisible. Factors. Okay, you can remove when you want. Oh, no. Okay, 54 is 1 over. Oh, yes. Look at that here. Cool. Very well. 54. Now 55. 55 I suppose que sí. Let me solve it here. 55 is 8 square. 8 square minus 9 divided by 8 minus 3. Simplify. Okay, I see clear. Okay, at the top we have different of the square. Okay, I open two parentheses, square root 8 square is 8, and square root 9 is 3, plus and minus. The bottom, nothing, because it's just easy binomial. 8 minus 3. This is 8, sorry. I copy we are 8, could look like 9, but no, it's 8. So now it's clear. This guy is cancelled. Chung chung. And stay alive. And the top, 8 plus 3. And the bottom, obviously, is 1. But this the intention for this example illustrate one idea. When the 1 is in the top, it's important to write. However, when the 1 is in the bottom, you can delete mentally, because divided by 1 is, when you have any expression, divided by 1 is any expression without 1. This 1 is completely useless. 8 plus 3. Boom. Final answer. It's okay. This is the algebra style. You know, you need to adapt to the algebra. Okay. Now I want to complicate a little bit your life, because in this example we have not only one fraction, we have two fractions separated by multiplication or division. In the case multiplication, this is k squared plus 10k plus 21 divided by k squared plus 13k plus 42. Multiplication, the second fraction is k squared plus 6k k squared minus 4k minus 21. Wow, I have no idea. But don't worry too much. We are doing step by step. Now I focus one by one and the expression that we have. We have 4 expressions. Okay, and I know I analyze one by one. Suppose I focus here. Step by step, guys. Don't frustrate. It's long, I know it, but this is not the problem for us. We are doing step by step. Well. The final, you get the same answer. I realize that this is the easy trinomial. Open two parentheses, you put a variable k, and you find the combination that open the door. Okay, my opinion is 7 and 3. Because 7 times 3 is 21 and 7 plus 3 is 10. So you put 7, 3 plus plus. In this case, it's obvious que plus because everything is positive in this trinomial. Let's focus in the bottom here. Again, trinomial, easy. Open two parentheses, KK. And the combination, I don't know, I suppose is 6 times 7, no? 6 times 7 is 42, and somehow 6 plus 7 is 13. Okay, yeah, it is 7 times 6. Remember, it doesn't matter because it's a factor, the position, but I put it, I don't know why, in my brain, I like so much put the bigger first. And now multiplication by this. So let's focus now in this expression. Okay, this expression is binomial, not trinomial. And this expression is no different of a square, no different of cubing, no cubing, no, it's GCF, basically GCF. The GCF is obviously is K. Okay. We factor K, and we have K plus 6. Cool. Now let's focus on the last expression. Last expression, I like this color. Okay, so this expression is trinomial. It's very, very similar to red one, but it's 21, no? But no. So it's open two parentheses, you put a KK, and the combination, 21, you know, is the classical 7 and 3, no? 7 times 3 is 21, but you get 4 subtraction maybe. 7 minus 3 is 4. Okay, this is 7 and 3, but 7 is negative and 3 is positive. Different sign, look, and the big number is negative and the small number is positive. So the long word is taking one by one expression and factorization one by one, bam, bam, bam. When you finish the factorization, this is the most important and funny moment in which you can see, wow. You cancel out, you cancel out any factor in the top and any factor in the bottom. Be careful. So you have the same factor in the top or the same factor in the bottom? No. So you need fraction. You need numerator and denominator. Because I know that any expression divided by itself is 1, and 1 is nothing. Now, one more. What I cancel out? I cancel out this and this. Because why no? In my mind, you suppose okay, this is a long line diffraction. Everything in the top belongs to the same fraction. Because what is the reason? Because the multiplication of the fraction is multiply top A times C divided by B times D. But basically, the multiplication of the fraction is too easy operation. Is the only you put together the number in the top and the number in the bottom, multiply each other, no? Okay, now, well, I can cancel out this guy and this guy. Boom. And who will stay alive? Stay alive in the top K. In the bottom, K minus 7. Boom. Final answer. You see this very complicated expression, and you reduce it in one equivalent algebraic expression. Because answer is A divided by K minus 7, like that. Boom. Cool. It's another application of the factorization. Simplify, reduce, and lowest term. Let's do another problem. Erase everything. Usual. Number 57. 7 is K squared It's a fraction. It's a fraction. K squared. So 14K. 45. K squared. Plus 16K. Plus 63. Times K squared plus 7K. K squared plus 10K plus 25. This is very, very similar. Okay. So now I can go to this expression. This expression is binomial, a trinomial, sorry. Remember, you can put together in only one fraction. So now I organize in that way. Two parentheses for the first trinomial. The variable K. Who helped me with to find the combination? What is the combination that give me 45 and 14? Open the door for this room, for this trinomial. Okay, 45 and 14.
9 and 5.
Super cool. 9 and 5, she said. And what sign, miss?
Positive, both.
Perfect. Let's move on to the second. The order is not important. You select the order you prefer. Suppose the second. Okay, this is open to parentheses again. KK. And what is the combination? Okay, open the door. Oh, it's weird. It's confusing. 63 and 16. 63 and no idea.
9 and 7.
9 and 7, very well. Because I know okay, 9 times 7 is 63, and 9 plus 7 is 16. Again, sign positive of, right? Oh, now I go to this binomial. Okay, the only possibility of the factorization is GCF. GCF is K. Entonces K times K plus 7. Cool. And finally, this trinomial. It's easy trinomial also. Okay. What is the combination? They give me 25 and 10.
5 plus 5.
Plus 5, very well. By the way, this is perfect square trinomial. By the way, it's easy doing, in this case, by easy trinomial. Ready to cancel out. Remember, one factor in the top, the same factor in the bottom. One more is cancelled. This and this. This and that. Stay alive. Okay? Over. K plus 1. Final answer. I guess so. Yes, it's this. Question. That's the reason that you need to be strong in the factorization. Yes or no? Strong. Factorization. Okay, now I want to, let me see. Oh no, this is easy. Okay, 58. 58 is another problem of the multiplication. It is x minus 8 over x plus 3. Oh, nice. Somebody do the job. The factorization we put together, no? I appreciate so much this. This is x minus 8 squared. Here is x squared by x minus 24. Okay. So this guy, I don't need to do anything. Nothing. And here, nothing. Because somebody, not me, do the factorization, yeah, I take advantage. Okay, because the only thing that you should do is focus in this guy. It's not factoring. Or open two parentheses, put the name of the variable is x. The combination, I am not sure. Help me, who help me? 24 and 5. Who opened the door? Two numbers can multiply each other. Give me 24 and somehow adding or subtraction. Give me 5. No idea.
8 and 3.
8 and 3. Very well. 8 and 3 because 8 times 3 is 24 and 8 minus 3 is 5. Do you see in my analysis? In this moment, to open the door, I don't care the sign. Now this is the crucial moment. Can you adjust the sign? It's different sign, it's the same sign. Who is positive, who is negative?
8 is negative and 3 is positive.
Absolutely perfect. Now ready to simplification. Well. Well, x minus 8, doesn't matter if this or this is cancelled with only one of these. And this is cancelled with this. Wow, disappear. X minus 8 disappears. And x plus 3 cancel one of these and one of these. And stay alive, only one x plus 3 in the bottom, yes? In the top, nothing. Nothing. Cool? 1 over x plus 3. This is the answer. Okay, so now we spend the rest of the time doing these two more problems of the division. So far, we start at the beginning with the one expression. You simplify one, only one. After two expressions multiply each other. However, now division. Division is similar, but bring me new situation. Bring me new situation. Okay. Let me copy. It's -4. 59. -4 plus 2x divided by 4. Division, be careful with the sign. Now it's division operation. 8 minus 4x divided by 8. There are many ways to do it. However, I recommend the easy way, in my opinion, is you copy the first, you have a numerator and denominator. So it's in this symbolic way, this is equivalent to say a over b. No? So now I copy the fraction. The first fraction is this. You copy it, stay the same. I don't touch. And you convert division problem to multiplication problem, and you flip it reciprocal. That's it. And now when you convert to the multiplication, you are doing exactly the same of the example we were doing before. End the story. Okay. It's the only thing. Change division problem to multiplication. How? Find the reciprocal of this. In general, this rule is valid. So suppose you have a over b divided by c over d. Okay. You can write another way to visualize this. A over b, c over d. So now you change like that. A over b, get the numerator part. I just bring down, copy. Don't touch. And multiplication and flip this. D over c. And multiplication. A, D, multiplication, B. This is the idea. But keep in mind, either way, see, you see in this way, it gets confusing, or in this way, you immediately convert to multiplication, and that's it. So let's come back to this problem. So now in this problem, Find GCF, find G, well, yeah. In that case, I see. Okay, in this part, let me focus it in this. In this, the GCF obviously is 2, no? 2 out. We have -2 plus x. Divided by, well, this is 4. We can break it down like a 2 and 2, but it's okay. It's numerical. Now, A is A. And this, the great common factor in that part is factor of 4. We have 2 minus x. Something like that, right? Okay, this is you dedicate to analyze the numerical part only. Let me show you. 2, 8, 4, and 4, no? 2 times 8 is 16. And 4 times 4 is 16. So the answer is 1. No numerical part. Okay, this is one way to visualize. Another way, personally I like, is, for example, is doing better by a couple of numbers. 8 divided by 4 is 2. You divide by 4, 4 by 4 is 1, and 8 by 4 is 2. You divide. And here, maybe you divide 2 by 2 is 1, and 2 by 2 is 2. And this 2 in the top, and this 2 in the bottom, it cancels. By the way, it's the same as 1. Numerical part is 1. Variable part, no. It's -2x plus x. Divided by 2 minus x. Pay attention this, okay? This brings me completely new idea, super important and super confusing. When you have any expression, divided by itself, they are identical, twin brothers. The answer is 1. This is the reason that we can cancel out. However, if you have any expression divided by opposite sign of this, it's the same guy, the opposite sign is obvious is -1. Make sense? Okay, I call these twin brothers. I call this brother and sister. This is funny. In the expression at the top, you see -2 plus x. And the expression at the bottom, I see 2 minus x. Do you see this expression have completely opposite sign?
Yes.
The answer is -1 in the story. It should be the same number. So you have, for example, another crazy example. 2 minus x divided by 2 plus x. They are no brother and sister. Because x is opposite, but 2 no. 2 is positive. It should be completely opposite sign. Minus here, whatever. So I suppose it's plus, it's a minus here. Oh, cool. And the idea behind this is elementary. Look, well, I have no idea. This brother and sister, I never understand this, no problema. However, in this example, you see a -1 is greater common factor. And you have 2 plus x. In the bottom, 2 plus x. Cancel out this and this. The answer is -1. Well, in our specific example, it was -2 plus x divided by 2 minus x. Suppose I make a decision, factorization -1. Maybe in the top or maybe in the bottom. No, it's not important. Maybe in the top. The factorization -1, but professor, -1 is not common factor because this is negative and this is positive. But I am forcing the situation. Put -1 like a common factor, and thus I have positive 2 minus x. Let me verify if I did well or not. -1 times 2 is -2. Cool. And -1 times -x is positive. Cool. I did well. I factor out, I enforce it. Actually, it's no common factor, but I enforce it to factor out -1. Yeah, and the bottom, no, and the bottom, no, and the bottom stays the same. I don't touch. You see that this is canceled, and the answer is -1. The fantastic conclusion is don't care too much for this. This is the proof. When you see that you have any expression, any, and the bottom and the top, you have completely opposite signs, the answer is -1. Of course, the number is the same, 2x, 2x. Suppose 3 plus x divided by -3 minus x. You see that this expression is positive, this expression is negative, the answer is -1. Cool? As you see 3 plus x divided by 3 plus x, or twin brother, the answer is positive. For the positive one, the recommendable idea is cancel out. No, actually, the shortcut that we create is when you see two, brother and sister, you cancel out, but a special cancel out, but you put -1. A -1 is not invisible. Positive one, yes. -1, you need extra negative in the game. Do you see the idea? Be warning for this, because not frequently, but sometimes happen. The answer is -1. Do you follow me or no?
Yes, we're following.
Excellent. Let's do one more, and that's it. Eric said yes. One more, and that's it today. And you enjoy your weekend. And now I need to go to the campus. I have another class in campus. Here I have tutoring to 5 p.m. Okay. I have to work. Okay, 60 is x squared minus 16 divided by 25 x squared minus 9 is division, I suppose. Division, no? You see, make it zoom. Oh, yes, it's division. Division who? Division by x minus 4 divided by 3 minus x. Okay, minus 5x, sorry. 5x. Step number 1. I don't like division problem. No. I convert to multiplication. How? Step the second. 9. 3 minus 5x. X minus 5. How we focus? Factorization, this guy. Oh, it's binomial. It's different of a square. Square root is x. Square root 64 plus or minus. Done. Factorization. That guy. Wow, it's another different of a square, binomial, right? It's open to parentheses. Square root is 5x. And square root 93 plus or minus. And now extending the line, because the time is extending the line. This is 3 minus 5x. And this is x minus 4. Nice. I like that. So now this is a funny moment in which you cancel out. In this case, is twin brothers. However, this is brother and sister. Let me using another color to the brother and sister. 5x minus 3 and 3 minus 5 is cancelled, but you put extra, -1. When this twin brother, no, extra -1. It's positive 1 is invisible. But my final answer? My final answer is minus, very minus is important, x plus 4 divided by 5x plus 3. I don't know, see, right like that. Oh, another way, let me see the answer. The answer is, yeah, it's the answer. Look at that, beautiful. It's the answer. Do you understand very well division and brother and sister and twin brothers?
Yes.
Yes.
Cool, so we finish, guys. We continue Monday, right?
Yes.
Okay, bye-bye.
Professor, before you go, I need to ask a quick question. I had sent you an email about overriding for MAC 1105. They said
Who are you? What your name is? Elsa.
Grace Love.
Ah.
I
Oh,
said,
Elsa is my teacher.
Ah.
I
I answered you.
yes, you answered
The
me,
problem is
but
the
they
problem is que this class is completely full.
yes,
It's
they
okay, but
said
it's okay. It's okay. It's okay.
yeah,
What is
they
your name?
they
What is your name?
Grace Love.
Grace.
Grace Love is my name.
Yeah,
But
I
they
know.
sent me a form that I sent to you on Canvas. They said that you need to sign it and then they'll allow me to be in the class.
Yes. One possibility is you email me. When I reply,
I
Bueno,
did. I sent it in Canvas. I sent it via email in Canvas. So I already signed it and filled out the information they told me to put in it, but they need your signature in order for me to submit it to them.
okay, I talked today to the chairperson.
Okay.
It include you and include another lady. Okay. Your name, repeat again. Your last name is Love, no?
Yes, Love.
And the first name?
Grace, Grace.
And the
It's
other is
called
Elsa, no?
Yes, professor.
Pero
They told me the same.
pero you solved the problem or no? Or not yet?
No. They told me the same, that you need to sign this for me.
Don't worry. Elsa, what is your last name, Elsa?
Caballero.
Caballero. Okay, I talked to the chairperson. I suppose that you are good students. I accepted my class I have 45 students. No problem. Bye.
Yes, I sent
Professor.
you. I sent the form via email in Canvas. So if you check your email in Canvas, you'll see the form attached. You just need to print it and sign it and send it back to me or to them.
Okay. This is the detail. Yeah. See, she accept, included in my classroom. Everything is fixed in Canva, in roster. No problem.
Okay.
Okay, guys, I gotta go.
All right, no problem. Thank you, Professor. Have a good
Are we
day.
Professor, are we gonna have a midterm or a final exam for this class?
No. We have the classical 5 tests, sorry. And that's it.
Oh, okay. Thank you.
No.